So next on our inspection and testing series, we are going to be looking at inspection and testing of low voltage cable to ensure their integrity, to ascertain that they will be safe for use till the next inspection and testing interval. So basically we have two types of tests that we can or we need to carry out on the electrical cables. Okay, this time low voltage cable. So we have both the visual or mechanical test, that is the physical test, and also we have the electrical testing that we can carry out on the cable. So as you can see on your screen, these are cables and these are the various specifications of the cables. Okay, so here we have the size of the cable, then we have the class of the cable showing us that is the insulation class of the cable. Then here is the amount of voltage for which that cable is designed, which means that this insulation can operate normally under this voltage condition. So the conductor type is copper, and this is the standard to which it was manufactured. So if you look at this, you see to this BS 6724, then this is the voltage rating and this is the conductor size. So this conductor size, as you well know, okay, this conductor size or this conductor size will determine the current carrying capacity of that particular cable. So the first thing that you need to look out for is to ensure that all of these parameters, the size or the current carrying capacity, okay, meets the specification of the cable for that part of your installation. So you compare the data on the cable as you see here. You compare those data with the specifications and also with drawings. So how do you do that, especially with a single line diagram drawings like this? If you are not too familiar with single line diagram, you can also check the description below. We'll drop a link to our training on the use of a single or the understanding of single line diagrams, okay, or of electrical diagrams generally. So here you have from your source of power, which is the generators, through your breakers, through your transformers, to this low voltage bus, and then to your electric motor. So remember, we are looking at low voltage cable, which means that we are going to be using those cable in this section of the circuitry, that is from here down to here, because this is a step down transformer. Are we getting it? Then now what we need to do is to check this parameter, the voltage rating of the cable, that it matches that of this section. So from all indication, from what we are seeing here, this one actually matches, okay, because here this bus we are having 480 volts and this cable can withstand up to 600 or 1000 volts, which means it can be used in those voltage environment. Okay, so which means that it is safe, assuming is this cable we are actually inspecting. Assume that this particular cable is what we are seeing here. Okay, so which means that it is safe, it will be safe for our use. Then another parameter we need to look at, as we said earlier, is the size of the conductor. Remember, the size of the conductor determines the current carrying capacity. Okay, so the amount of current that will be flowing through the conductor is determined by the load that is attached to that particular conductor. So here now we have this particular motor. So the normal running current of this motor will determine the size of the conductor that we'll be using here. And also too, we need to put into consideration the starting current of this. So if you go to your cable chart or data sheet, you will see the current rating for the different sizes of cables. So if the current rating of this matches that is expected on this particular part of the circuit, that means the selection is okay. It means that we are good. If not, we need to reconsider. So the next thing that we need to look at is the exposed sections. The exposed section of the cables. We need to look if there are any physical damage. Okay, the insulation, if anything has happened to it, if it has been damaged, and we know if it is damaged, that will drastically reduce the insulation of the cable at that particular point, and thus reducing the integrity of the cable. So we need to check out for any physical damage on the cable. So next, what we need to do is to look physically at the connection points, whether there are any visible signs of high resistance at those connection points. So those visible signs could be metal oxides, those whitish substances or greenish substance deposited on this the conductor on at this particular terminal point, okay, where the cable, where it is terminated. So if there are those metal oxide, those are clearly signs of high resistance point. So what we need to do is to clean up, retighten the bolt. So we'll see how to determine the torque level later. The normal torque level, which is dependent on the size and the grade of the bolt. So like we said earlier, you check with specification if it is a newly supplied cable, or if it's a cable that you newly want to install, it's a new installation. You also need to check to see that the cable actually meets the specification of that section that you are installing, you want to install that cable. Okay, that is before you install it. So you look at all of these parameters to be sure that it meets specification. So next, what you need to do, you look at this terminal log, okay? These terminal logs to be sure that the actual size is selected for the cable. Be sure that it is not oversized, because if it's oversized, the cable will be floating in the terminal log, and if the cable is floating, that will give an avenue for loose connection that will eventually result to high resistance point that will result eventually to hot spots, because the amount of heat that will be dissipated at that particular spot will definitely go up because of the looseness, and then that will become a potential point or a point for potential failure on your installation. So you want to look at the size. If it is 120 mm, if it is as a smart 120, that means the cable is 120 mm, okay? And you see the size marking there, be sure that it's the size. Then if it is smaller than the cable, it means that the installer, or when you want to install, if it's a new installation, you may need to cut out some of the strands of the cable before you can fix it into the log. So when you do that, what you have done is that you have reduced the cross-sectional area of the cable at that particular point as it's entering the terminal log. Okay, so once that happens, it means that you have increased the resistance of the cable at that point. And once the resistance is increased, it means that the amount of heat that will be dissipated will also go up. So we want to be sure that we use the right size of the terminal log. So the next thing that we want to do is to check these terminals, that it has the required pressure, okay, the required torque level this terminal, the boats, they are torqued to the required level. So you need a torque wrench for this, okay, a calibrated torque wrench. So in using that calibrated torque wrench, you need to torque it to the level that is specified by your facility for these terminals. Okay, so if this is an equipment, the equipment manufacturer may specify the torque level that you can drive these nuts or bolts to. So you have to take it to that, drive it to those torque levels, all of these terminals of the connections. Okay, so if you do not have what is specified for your facility, you can use this table. So in this table, you see that we have this table for torque value for electrical connections. So if you look at this table, you see that we have different torque values for different sizes of bolts in electrical connection, and also for different grades of bolts. You see the SAE 1 and 2, 5, 7, and 8. Okay, so the different sizes of these bolts, they have different torque level. So let's assume that we are looking at an SAE grade 5 bolt and SAE 5 bolt. Okay, and that SAE 5 bolt is or not is half inch. Are you getting it? So the torque level to which we would drive that half inch grade 5 bolt is 48 pound-feet. So that is the level to which we will drive it to. So it's now left for you to look at the grade and size of the nut or the bolt and then apply the appropriate torque level for each. So the next that we are going to look at is the identification of this cable. We want to be sure that the correct identification is done, okay, on each of these cable. So as you can see, we have phase markings. All the red, they are of different phases. The green, of course, different phases, and the yellow, they are of different phases. So we can also mark on it the part of the circuit that the cable is either going or that is coming from, or the particular equipment that it is supplying. We can also have those markings on it. So that will tell us clearly where the cable is going or where it is coming from. So those are some of the things that we inspect when we go out to inspect already installed facility. So you can also look at the insulation of the jacket, that is the part that is covering the conductor. Okay, the part that is covering the conductor, you look at them to see that there are no damages on them. Are you getting it? So if there are damages on them, as we said earlier, that will drastically reduce the insulation of the conductor. Okay, because that jacket is meant to insulate the conductor. So once there are damages on them, the insulation has been compromised, and that means the integrity of the cable has been compromised.